Okay, good morning, pre-calcers. We're going to look at section 3.5 today, which is going to seem very familiar because it is a combination of two previous sections. So there's nothing too drastically new today. You're going to see a few different kinds of equations, but it's mostly the algebra and the solving that you're going to need to be careful on. You might want to have your calculator out and typing the things in as I am so that you can make sure you're typing them in correctly. We've got the exponential growth, exponential decay, and continuous growth models up here at the top. I'm also going to have some problems with half-life, which we'll do in a little bit. Okay, so the first problem is, given you invested $5,000 in a savings account earning 4.5% compounded continuously, that's the key word, continuously, how much money will you have after 15 years? Okay, so continuously means we're going to use this formula, the PERT formula. How much money will we have after 15 years? Well, we started with 5,000 and our rate is 4.5%, so we have to move that decimal place 2 over, so it'd be 0.045 that we put in for the rate. And it's over 15 years, so 15 goes in for t. So you should be able to just type this straight into your calculator and get the answer. So you try typing it in and see if you get the same thing I do. Okay, so I got 9,820.16, and it's money, so put the dollar symbol. So $9,820.16. Okay, did you get the same thing? I hope so. Okay, the next question says, how long will it take to triple your money? Okay, so again, we started with 5,000 and we've got e to the 0.045 and it's asking how long, so we don't know what t is. We're going to solve for t. Well, what does it equal when you triple your money? So tripling would be 3 times 5,000, so 15,000. Okay, now in order to start solving, we have to isolate the exponent. So we have to divide out the 5,000. So 15,000 divided by 5,000 is 3, which makes sense because we tripled. Okay, now that we've isolated the exponent, we're going to turn it into a logarithm. So it'll be log base e of 3 equals 0.045 t. And if you want to say natural log of 3, you can. And all you need to do to get t alone is to divide by 0.045. So natural log of 3 divided by 0.045 will give us our time. And type it in. I think we should get 24.41 years because time was in years. You can have a portion of a year, so leave it as a decimal like that. Okay, next problem. Now this is an equation that you haven't seen before. This is a logistic model. Logistic models look like this. They have a horizontal asymptote down there and a horizontal asymptote up here. They've got two horizontal asymptotes. This is when something grows kind of slowly, then picks up some speed, and then levels off. So here's our example using this logistic model. In a high school of 1,200 students, one student returns from vacation with the swine or swine flu. The spread of the disease is modeled by this equation. How many people will be infected after 5 days? T is time, so all you have to do is plug in a 5. So all you need to do is 1,200 divided by 1 plus 1,999 e to the negative 0.7 times 5. Okay, so you practice typing that in your calculator to make sure you got it correctly. I'll do it too. All right, I'm getting 19.55. Now, this is people, right? So give the exact answer, and then you can do your rounding. Some people might argue 19 people, some people might argue 20 people, because 0.5 should round up, right? But I'm going to argue rounding down, because we don't even have enough of a person to make another full person. But always show the exact answer first and then do your rounding. Okay, the next question. Really follow along on your calculator with this one. School will shut down if 55% of students are sick. After how many days will the school shut down? So we're going to solve for T because we're trying to figure how long it takes until school shuts down. 55% of the students, how much is that? Well, we have 1,200 students. So what's 55% of 1,200? We would multiply by 0.55. 1,200 times 0.55 is 660. Okay, so when it reaches 660 students, we need to shut the school down. So where do we plug the 660 in? Into Y. Okay. I'm worried I'm going to run out of room on this one. Okay, 660 equals 1,200 divided by 1 plus 1,999 e to the negative 0.7 t. Okay, we're going to solve this for time. First thing I would do is I would put the 660 over 1 and I would cross multiply. So 1,200 equals 660 times all of this stuff. Okay, now I would not distribute the 660 through. Instead, I would divide by 660. Okay, so 1,200 divided by 660. Let's see what that is. That's about 1.82. Okay, now our whole goal is to get this exponent isolated. So we need to get rid of the 1, subtract the 1. So now we have 0.82 equals all of this. Still, we want to isolate the exponent, so now we're going to have to get rid of the 1999. So divide that out. Now, when I'm using my calculator, I'm using the full decimal from this. I'm not rounding. It looks rounded as I'm writing it out on paper, but I'm leaving the full decimal in my calculator. So I have I have 0.81818181 in my calculator, and I'm going to divide that by 1999. Okay, and now you're going to possibly get something that looks like 4.09 e negative 4. That's times 10 to the negative fourth. So you would move the decimal 4 places to the left. So that would be 0.0000409. It started with 4.09 and we moved that 4 decimals to the left. So 1, 2, 3, 4. And that equals e to the negative 0.7 t. Now we've isolated the exponent. So now we're going to turn it into a logarithm. So log base e of that small decimal, so log base e of 0.000409 equals negative 0.7 t. So log base e is the same thing as natural log. So I'm going to do natural log, and I'm going to use my previous answer so that I'm not really typing this in the calculator. I have it looking like it's rounded on paper, but in my calculator I have the original longer decimal. I'm going to do ln of that, and I get negative 7.801 ... there's more to it. And now to get time alone, I have to divide by negative 0.7. And I get 11.14 for time. And time is in days. So in 11.14 days, they're going to have to close the school because then 55% of the students would be sick. Okay, a half-life problem. Here's your half-life formula. A sub 0 is the initial amount, T is the time, and K is the half-life. And you'll be given the half-life. Okay, if 10 grams are present initially, how much will there be in 19,000 years? And the half-life is 5,730 years for carbon-14. So how much will there be? Okay, well, we start with 10 grams. Time, how long is this going? It's 19,000 years. And the half-life is 5,730 years. So type all that in your calculator. Okay. All right, so I'm getting 1.0042, and we're talking about grams. So it started off with 10 grams, and in 19,000 years, there's 1.0042 grams. Okay, this is another kind of problem. Actually, what I'm going to need to do is I'm going to need to stop this video, and then I'm going to record part 2. So you're done with this one now. Now click on part 2, and I'll pick up on part B here, and I've got 2 more examples to do. Okay, so watch part 2 now.